Next, we are going to see about power semiconductor switching circuit for SRM. SRM is nothing but switch selector symbols. It's nothing but power controller of SRM. The selection of controllers is nothing but selection of converter depends upon the application. The one main aspect of SRM price has been converter design. The main objective of design of converter performance of drive and cost of the drive. The power semiconductor switching devices used for two power semiconductor switching devices per phase and two diodes, N plus 1 power semiconductor device and N plus 1 diodes, phase winding using bifilar wire, splitting circuit using even phases, and C-dump circuits. Next one is the two power semiconductor switching devices and two phases diodes. This is a diagram for two power semiconductor switching devices and two diodes. That means it consists of three limbs. Each limb carries the two semiconductor devices and two diodes connected to the phase winding. Similarly, second limb and third phase windings. So, then the phase winding A is connected to the DC supply through the power semiconductor device T1 and T2. Depending upon the rotor position, the phase winding A is energized and the device T1 and T2 is turned on. When the winding is disconnected, when the winding is disconnected from the supply, the T1 T2 is turned off and the stored in the phase winding A is to maintain the current in the same direction. This current passes to the winding to the D1 D2 supply. Similarly, the process is based with B and C. Then N plus 1 semiconductor devices and N plus 1 diode. This is the diagram for the N plus 1 diode. That means each phase winding carries the two semiconductor, first phase winding carries two semiconductor devices and second one carries one phase winding carries one semiconductor devices, third one also one diode. So each carries one diode and one phase winding. Here, the circuit makes the user less number of power switching devices and diodes. So the switching device T and T1 are turned on. The phase winding A is energized from the supply. When these devices are turned off, the stored energy in the phase winding is fed to the main through the diode D and D1. When the device T and T are turned on, the phase winding B is energized. When they are turned off, the stored energy B is switched on or off from the mains. The cycle gets repeated. The circuit makes N plus 1 power switching devices and N plus 1 diodes. Then the phase winding using bifilar wires. Here, each phase winding consists of one semiconductor devices and one bifilar wire is magnetically coupled to the phase winding, and this bifilar is connected to the diode. Similarly, phase winding B and C. Each phase winding has two exactly similar phase windings, as shown in figure. These bifilar wires are used for each phase consists of two identical windings and magnetically coupled, one of them are excited. When the T1 is turned on, the DC current passes through the phase winding A. When the device is turned off, the stored energy in the magnetic field is fed to the DC source through the winding A dash and D1 supply. The three devices operate in a sequential way depends upon the signals obtained from the rotor position sensor and chopping signals for PWM techniques obtained from the control. Next one is C-dump circuits. See, this is circuit diagram for C-dump circuits. In the devices count reduced to n phase pulse and one additional device is bleed to store energy from the dump capacitor back to the supply via step-down chopper circuit. The main capacitor voltage maintained well above supply to permit the rapid defluxing after commutation. A control failure in the every recovery circuits would result in a rapid build-up change on the capacitor. Protective measures were not taken. The entire converter would be failed from the over voltages.